Welcome to Study Loop.
F is a quadratic function, f of 0 is 1, and we're given that this integral is a rational function, and we'd like to find f prime of 0. So let's come back up here and use this information. We have f of 0 equals c equals 1, so that gives us c. So we have f of x equals ax squared plus bx plus 1. And the thing that we're after is f prime of 0. So that's just b. So we'd like to find the value of b such that this thing is rational function. So that'll determine the possible values for b. So let's go ahead and do partial fraction decomposition. So right now our integrand is f of x, which we know is that up there. And then we have x squared, x plus 1 cubed. Now using what the author calls case 2, I can write this as a over x, b over x squared. And then using case 2 again, this time for x plus 1, c over x plus 1, d over x plus 1 squared, e over x plus 1 cubed. Oops. And then let's go ahead and multiply. Well, actually, at this case, before we multiply, we may not have to here. Let's just note that we want this integral to be a rational function. So, in particular, rational means we don't want logarithms. No logs here. So that automatically eliminates these two terms here. We do not want these terms because these give us natural logs. So this gives us a and c are both 0. So when I go ahead and multiply both sides by this denominator, and we're getting rid of a and c, let's go to the next page. I get ax squared, bx plus 1. And then on the right, and then we could go ahead and solve this. So go ahead and expand this out and then combine based on the power of x. So pull out a x cubed, pull out a x squared, and that's what we're doing right now. So that's when you pull out x squared and then 3bx and then b. And then we end up with 3b equals little b. A large B is 1. So that gives us b equals 3. And that's exactly what we wanted because remember from the previous page, we wanted f prime of 0. We knew that was b. The b over here in front of the x. And we just found that value of b. That gives us 3. And that's our final answer.